All right, eighth grade, good morning. We're continuing along here in lesson 5.3, where it says solve the system by elimination, check your solution. Now, in 5.3a, we focused on addition and subtraction. Today, we're going to focus on multiplication and division. So we've got a couple examples that we're going to look at. The second part of your assignment today kind of goes back and has you review some of the other methods. So you might want to go back if you need a refresher and look back at the earlier videos for chapter 5. But this video is solely going to focus on multiplication and division, and it's pretty much just multiplication that we're going to use. So solve the system by elimination, check your solution. Now, we got two examples that we're going to look at today. The first thing you always want to make sure of is that the like terms are lined up. You don't have to make slope-intercept form or anything like that. I mean, you could ultimately, but that's not going to be the best way. The goal is here, eighth grade, to have you look at different examples of systems of linear equations and be able to make decisions about how you should handle those. And we'll review these later in the year when we get into some algebra stuff, but some good exposure for right now. So we have x plus 4y equals 1, 3x plus 5y equals 10. Now this first one, the like terms are already lined up. Here we have the x, here we have the y, here we have the regular number. All right, now yesterday we focused on being able to cancel things out based on addition and subtraction. And so that's our goal, okay? That's our goal of what we want to do. Now, when I'm looking here, okay, I'm seeing, okay, I've got x and I've got 3x, okay? And so what I'm going to do is my goal is to make everything the same, okay? My goal is to make everything the same, or at least make something the same that I can cancel out. So I'm going to look at the x and the 3x, and I'm going to say, well, I can multiply this first one by 3. Because if I multiply this by 3, this one's going to be 3x, and this one's also going to be 3x. Okay? Sometimes, as you're going to see in the second example, I've got to multiply both of them to change. All right? And so we'll talk about that later. But in this one, I only need to multiply this first one. And I'm going to multiply it by 3 because that's going to make this 3x. And then that's going to be the same as this, 3x. So I can cancel it out. 3 times x is 3x. A plus 4y, a positive 4y times 3 is a positive 12y. And then 1 times 3 equals 3. All right, so once again, 3 times x makes 3x. 4y times 3 makes a plus 12y. 1 times 3 makes 3. So I'm going to go ahead and cross this off so I don't get confused and accidentally look at it. Now I go back to what I did in lesson 5.3a, and I say, okay, am I going to add or subtract to cancel things out? Well, I'm going to go ahead and I'm going to subtract because 3 minus 3 is what makes 0. So 3 minus 3, I'm going to go ahead and put a minus sign there. 3 minus 3 is 0. 5 minus 12, a positive 5 minus a positive 12 is a negative 7y. And then 10 minus 3 equals 7. All right, most of the time, as you know, the numbers will work out in some way. Now, to isolate y, obviously, I'm going to divide everything by negative 7. So y equals negative 1. All right, so now I'm saying, okay, now I want to go back and kind of look at what my initial examples. Okay, now I can go ahead and take this y equals negative 1 and plug it into one of these, or what I can do, I know that x was isolated here, okay? And so if I go back to what that equation was. It was x plus 4y equals 1. I want to try to use the simplest equation that I can possibly use. So I'm going to go ahead and stick in y equals -1 here. So that's going to be x plus -4, which is essentially x minus 4, equals 1, because when I add a negative, 4 times -1 is -4. A plus -4 is a minus 4. X minus 4 equals 1, which means that x equals 5. If I add 5 to both sides, that gives me nothing here. 1 plus 4 is 5. That means that my intersection point, remember that's what the solution of linear equations is the point of intersection. X is 5, y is -1. All right, let's look at our second example for today. 5x equals 4y plus 8, 3y equals 3x minus 3. Well, first of all, they're not lined up, so I need to get them lined up. All right, we already have x isolated here, so I'm going to go ahead and add 3 to both sides. That's going to make 0. And then I'm going to come over here, and this is going to be 3y plus 3. Okay, because there's nothing, no like terms there, so it's like nothing plus 3. Which means, let's get everything organized. 5x equals 4y plus 8. Let's go ahead and get things lined up. I know that the 3x is by itself, so we're going to have 3x there, and then that equals my 3y plus 3. So 3y plus 3, okay? So I want to make either my x or my y the same. Now, the first one, it was nice because I could just multiply this first one by 3 and it made it 3x. Now that's not going to work because I can't take the 3 and turn it into 5, can't take the 3 and turn it into 4. So this works a little bit differently because now I'm going to have to change both equations, okay? Now in the first one, I made the x the same. So in this second one, let's just do it a little differently. We're going to make the y the same. I've got 4 and 3. So I'm thinking that the least common multiple, the smallest number that both 3 and 4 can go into, would be 12. To make this 12, I would have to multiply this whole thing by 3. 4 times 3 is 12. To make this 12, I'd have to do 3 times 4 is 12. So I'm going to have to multiply everything here by 4. So if I take this one, and I multiply everything by 3. 3 times 5x is 15x. 3 times 4y is 12y. 3 times 8 is 24. Then I have this. 4 times 3x is 12x equals 4 times 3y is 12y. 4 times 3 is 12. My goal is to get two things the same, and now I have 12 and 12 the same. Now to get to 0, to cancel them out, I'm going to have to subtract. Well, I don't need the -1, but I'm just going to be subtracting. All right, 15 minus 12x is 3x. 12 minus 12, that cancels out. 24 minus 12 is 12. So I end up with 3x equals 12. Well, if 3x equals 12, I'm going to divide everything by 3. 12 divided by 3, x equals 4. All right, so let's take x equals 4. I'm going to go ahead and bring over my other board here. If x equals 4, okay, and I'm going to go ahead into one of my other equations here. Let's just go with this first one, okay? We'll say 5 times 4, if x equals 4, 5 times 4 is 20. So it's going to say 20 equals 4y plus 8. 5 times 4 is 20. 20 equals 4y plus 8. So I'm going to say 20 equals 4y plus 8. All right? Well, my goal is to isolate the y. So I'm going to subtract 8 from both sides. That's going to give me 0. I subtract 8 here. That's going to give me 12. That leaves me with 12 equals 4y. Well, if 12 equals 4y, I'm going to divide everything by 4. 12 divided by 4 is 3, so y equals 3. Well, x equals 4, y equals 3. That means that my intersection point is 4, 3. That's where those two lines intersect. And that would be the solution. If I want to double check the 4, 3, if y is 3, 3 times 3 would be 9. And if x is 4, 3 times 4 is 12. 12 minus 3 equals 9. Sure enough, 9 equals 9. That's another way you can just double check, plug the numbers into the other equation. All right, talk to you later, 8th grade. Bye.